This video demonstrates best practices for setting up interior elevations utilizing external referencing of a floor plan view. First, let's talk about orthographic drawings and specifically interior elevations, which are a type of orthographic drawings. Orthographic drawings define a particular object or a part of a structure and are constrained to only two dimensions at a time, such as width and height. Compared to perspective views, depth is not expressed in orthographic drawings, not in the sense that you might be familiar with. There is a way to manipulate some sense of depth in orthographic drawings, and that is done through the use of line weight diversity. We'll talk more about that later in the video. But first, if you have not yet watched the video entitled External References, Xref, you should watch that video demonstration before proceeding here. Let's start by setting up a new file. If you are following along with me in an in-person class or as an online class with the Kindle Hunt publication, I recommend downloading the file provided for this lesson, your AutoCAD drawing.dwg. Immediately save the file as your last name, elevation, kitchen.dwg. Make layer 0 the current layer. In AutoCAD, use the Xref command to deploy the reference manager. On a Mac, the Xref command is located under the Window pull-down menu. On a PC, the Xref command is located on the Insert tab and on the Reference panel. From here, browse to find the most updated version of the Gatekeeper's Lodge drawing and select this file as the reference file. Make sure that the settings for the Xref match those seen here. Pick OK. Zoom Extents. Let's repeat this process on a PC. We are not using the entire floor plan for this assignment. We will suppress the drawings such that only the kitchen is visible. To do this, use the rectangle command to make a boundary around the kitchen area. Deploy the XClip command by typing XClip at the command line. On a PC, this can be done from the Insert tab on the Reference panel. Locate the XClip button. Next, AutoCAD command line indicates to you that you need to select the external reference file. Pick anywhere on this drawing. From the command line, choose New Boundary. Choose Polyline. Pick on the rectangle that you just created. You should see the rest of the drawing suppressed. I will now repeat the XClip command in AutoCAD Mac. Use the rectangle command to make a boundary around the kitchen area. Deploy the XClip command by typing XClip at the command line, or go to the Modify pull-down menu to Clip and then Xref. AutoCAD command line indicates to you that you need to select the external reference file. Pick anywhere on this drawing. From the Clip list of options, choose New Boundary, choose Polyline. Pick on the rectangle you just created. You will see the rest of the externally referenced file disappear, and only the area contained within the rectangle is now visible. The next part of the video uses the Xref file as the basis for creating a projected elevation view drawing. The process I will describe ensures that there is a drawing agreement or accuracy between the plan view drawing and the elevation drawing. It is essential that all of the object lines align through the orthographic projection process I will now define. Using the construction line command, type XL, return Enter key. Place a horizontal construction line along the exterior wall. Offset the construction line. Set the offset distance to 5 feet. This new construction line will represent the line where the floor and the wall of the kitchen located at the sink intersect. Offset the construction line that represents the floor. Set the offset distance to 9 feet, which is the floor to ceiling height of the kitchen. Place a vertical construction line along the interior wall of the kitchen plan view. Do this for each interior wall as you see me do here. You can now see the basic outline of the kitchen elevation. I want to draw your attention to the AIA layer type guideline that was provided to you in the first assignment for this class. You will need to create the following layers for the elevation drawing. On the I-ELV-heavy layer, I will draft a rectangle from corner to corner, where the construction lines intersect one another. Explode the rectangle so that the lines are now individual lines. Note that elevation layers are not typically defined by objects. Instead, elevation layers are defined by a series of layers that help us achieve line weight diversity. Therefore, instead of placing the elevation countertop lines, say, on the C-top layer, we will utilize the I-elevation-medium layer instead, because the line types are a medium line weight. This may seem strange to you at first, but it will be useful to you later to separate the plan view layers from the elevation view layers. Now that you have the outline of the kitchen elevation, it is time to begin the process of projecting the lines from the plan view to the elevated view. Each cabinet line will be projected from the plan view directly into the elevation view using the construction line command. Refer to the multi-step handout for a full description of how to manage specialty cabinets and the modification of the cabinets with the block library you created in previous lessons. Finally, the last thing that needs to be included in the general setup of the interior elevation is the insertion of the window assembly, which was provided to you as a W block. Insert the window W block. The location of the window should be established by using a construction line projected from the plan view. Locate the height of the window by establishing either the sill height or the header height. For example, if you choose to locate the window at a typical header height of 7 feet above the floor, this is how the window will appear. By placing the top of the window at the 7-foot header height, you can see this leaves only 3.5 inches between the bottom of the window and the top of the cabinet. Using this method of locating the window in the elevated view does not give us enough vertical space when the thickness of the countertop is added and the 3-inch frame that will be included in the final window detail later. Therefore, the method of locating the window by the header is not useful to us in this instance. Let's look at another method next. Alternatively, you can choose to locate the window by the sill height, placing it 8 inches above the countertop height. The countertop height is located 36 inches above the floor line, as represented by this line here. Offsetting the countertop line another 8 inches will give you the bottom of the window assembly. In the final elevation, you will place a 3-inch frame around the window assembly. You may want to do that now, making the new distance from the countertop to the bottom of the window frame 5 inches. Another W block that has been provided for you is the elevation symbol. You may want to insert that into the plan view now. In addition to these W block assets that have been provided for you, you have been given a D-size title block. Another write block that has been provided to you is the D-size title block containing attribute text. Refer to the video on setting up the architectural D sheet for a review of setting up the paper space sheet and title block provided. Once you've completed all of the steps in the graphic handout that will walk you through the different aspects of drafting an interior elevation, you will want to adjust the line weight settings to achieve a visual hierarchy. What does that mean? The term visual hierarchy encompasses a couple of ideas. Remember, in an orthographic drawing, only 2 dimensions are expressed at a time. To be able to manipulate the perception of depth in this flattened out type of drawing, we create a system where the darker lines appear closer to the viewer than lighter, thinner lines, which we perceive as further away from the viewer. Another goal of visual hierarchy is to help the viewer understand the drawing easily. The heaviest, thickest lines should be the lines which seek to define the drawing type. In a plan view, these are the wall lines. In an elevation view, this becomes the floor, walls, and ceiling outline of the room. It takes some time to come to a combination of line weights that makes your drawing read with clarity. When you change the viewport scale of the elevation, that will also impact the visual hierarchy. Drawings shown at larger scales, such as 1/2 inch or 3/4 of an inch equals 1 foot 0 inches, will appear to have much lighter and thinner lines than drawings depicted at smaller scales, such as 3/16 or 1/4 equals 1 foot 0 inch scales. AutoCAD provides the ability for us to define line weight assignments per viewport, as well as general line weight assignments to the drawing. This is why you've been provided a range of line weights in the AIA layer type handout. To change a line weight in a particular viewport, activate the viewport you want to affect. Then go to the Layer Manager. Locate the column for VP, or Viewport Line Weight. Notice that by adjusting the line weight here, I am not affecting the general line weight definition for the entire drawing. Visual hierarchy and line weight diversity are concepts that are important to intermediate and advanced AutoCAD users and students. This concludes the video for best practices for interior elevation drawings, in which the topics covered included using the external reference command and XClip commands, using the construction line command to project object placement from the plan view drawing to the elevation drawings. The 2 different considerations for locating a window in elevation were described, which included setting the window height based on the header height or based on locating the window based on the sill height. This video concluded with a discussion of the concept of visual hierarchy within drawings and how to create line weight diversity using layer management and viewport line weight settings within a drawing.